So hello everyone and welcome to this EDITO workshop that we co-organized for you. My name is Gaëlena Sterbik and I'm EDITO User Support and Capacity Development Officer at Mercator Ocean International, and I will be one of your hosts for today. So over the course of this training, we will explore key aspects of the EDITO platform and what it offers. So we will tell you what EDITO is about, what sort of data, models, and applications you can find, and most importantly, show you how you can use it for your work. Before we start, I'm just going to go over some guidelines to make sure you enjoy this webinar, as almost everyone is on site. So first of all, you should have the link to the webpage of the event. And on the website, you will see a dedicated Q&A section. So you will find it on the top bar of the web page, and you can click it open to open the dedicated space where you can ask our speakers your question. And in the same section, you will also find a short survey that you can answer at any time during the session. And also, just to let you know that the session is recorded and the slides will also be available. So I will upload everything on the website in a few days, and I will let Camillo know to let you know afterwards. Concerning the agenda for today, we will have 5 presentations and demonstrations. So I will start with an introduction to the EDITO project, and then Mathis from Mercator Ocean will give you a presentation and an overview of the EDITO platform and the data lab. And after that, Lerint Metzaros from Deltares will show you how to create applications on EDITO. And finally, Samuel Fuchs from the Flanders Marine Institute will present to you how you can contribute to the EDITO platform. And as you know, also after the coffee break, Camillo, that you already know, will give you some work on a case study to interact with EDITO using the validation toolbox. Okay, so now we will go into the short presentation of EDITO. I apologize in advance to everyone who's heard Marina Stonelli presentation from 2 days ago. I will probably repeat most of the things she presented, but yeah, it's just to introduce you for the person who didn't heard it. At the start of 2022, the European Commission President Ursula von der Leyen announced a new public service, the European Digital Twin Ocean. It's a virtual replica of the ocean that makes ocean knowledge available to everyone. So it integrates data from many different sources, including satellites, sensors, models, and even personal devices like smartphone applications. And these different data sources constantly feed the digital twin to provide continuous and up-to-date information about the ocean. So it goes from the behavior of marine species to chemical processes, economic activities, and much more. It also provides both historical and near real-time information about the ocean's real-world conditions and processes, which can then be used to simulate real-world scenarios and predict their outcomes. You will find there short videos on the project that will be available once the slides are on the webpage if you want to take a look. And so what's the difference between the European Digital Twin Ocean and EDITO? So EDITO is the public core infrastructure platform for the European Digital Twin Ocean. So it offers tools to those building digital twins to co-create the European Digital Twin Ocean. And it supports science-based decision-making and ensure maximum impact for marine research and innovation actions. The EDITO service offers an innovative knowledge ecosystem, so it evolves and scales up to expand its reach beyond expert users and developers. So EDITO also wants to speak to non-expert users. And yeah, the main goal is to make ocean knowledge available to everyone, so from policy and decision makers to scientists and citizens. So yeah, the EDITO project has been here for 3 years now, and between 2022 and 2025, the development of the platform began with two European projects, so EDITO Model Lab and EDITO Infra. EDITO Model Lab delivered next generation ocean numerical models, focus applications, and what-if scenarios to be integrated into the platform, while EDITO Infra integrated key components of the existing ocean observation, monitoring, and data infrastructure into a single digital framework. So together, these projects built the foundation of the European Digital Twin Ocean, and today, EDITOs continue for the next 3 years until August 2028 in the EDITO 2 project. So it will continue to expand its community and to construct a fit-for-purpose digital twin ocean. And the goal is to have by 2030 a fully operational DTO platform to serve as a global benchmark for digital ocean solutions. And yeah, just a quick timeline of the last 3 years. If you want to have more details, I am not going to present it in detail, but you are more than welcome to take a look. And you will also see there all of the actors involved in the first place. So what's next for EDITO? So in the current phase, the goals are to grow the technical capabilities and the community of users. So EDITO is working to develop the collaboration across public, private, and civil sectors, enhance services for researchers and modelers, and ensure its accessibility to non-expert users, and to drive the engagement of the community. So it can go through collaborations, open calls, hackathons, several types of events. And it's also contributing to international activities and projects via grant calls, sorry. So yeah, as you might have understand, EDITO is nothing without its users. So during the scope of EDITO in the next 3 years, there are 3 grant calls that are being opened. The first one will open mid-January, and it will be open for 2 months for the duration of 10 months after for the project. So it focuses on existing or near final applications model or data that we want to test on the platform. So if you are interested and if you want to engage with this, you will find the link to register to an explanation session. So it will be on the launch call number 1. So you will be able to find the link with the slide. Concerning also the EDITO user support and capacity development activities, so it's a task called Services and Operation, and which is about delivering an effective support and an optimized user experience. So it evolves around 3 main points: providing a multi-level user support to all of EDITO users, to also work on the scientific validation of the data, models, and applications available on the platform, and to implement capacity development activities, so with tutorials or training sessions. And in 2026, we are planning on having 3 of these trainings like this one. So yeah. Okay. And yeah, finally, my last point. So you've probably already done this for the training, but you know that you can register and request computing resources on the platform to use EDITO. So in the next presentations, you will see examples of what EDITO offers and how to create applications and contribute to the platform. And so yeah, these are the 3 levels that EDITO is structured around, and you will also see more detail on the EDITO platform here and on a short explanation video here. if you want more details. And yet, that's it for me. So we'll go to Matthis' presentations. If you have any question, don't hesitate to use the Q&A tab on the website, and we'll display the questions on the screen after each presentation for the speaker to answer them. So Matthis, whenever you want, you can start sharing your screen.
Yes, thank you, Gail. You should be able to see my screen now. And I'm going to present or do an overview of EDITO and its different component that you can use and play around with. It's going to be a quick overview, and after that, Loring and Sam are going to go into more details about how to use the platform. So to dive into EDITO, the first page that you need to go to is our main entry point, the dive.edito.eu website. On this page, you will find all the links that you need to start using EDITO and browse its various components. We also showcase a set of applications that are deployed on EDITO and that you can explore and play around with. So as you see on the top bar, you have the different links to the different components. So the viewer, the data lab, the trainings, etc. So for the trainings, it's a set of articles and tutorials made by the community that are linked to processes or services on EDITO. So you will find documentation on how to use the application or what are they meant for, etc. So if you want to deploy something on EDITO to contribute to EDITO, you can also write a tutorial or training with it that you can host directly here, and that will help you or that will use your work. After that, we have a viewer in which you can explore the our data catalogs that are sorted into different categories. So you can browse the data that is available, display it on a map. You have also some integration if you want to use the data directly into EDITO. It's a good place to see what data is available, what the platform offers, what people or the community have contributed in terms of data. Then you have the documentation, very important page or website or component where you can find almost all the information you need to use EDITO, to contribute to EDITO. You have a lot of different use cases that you can browse and so if you have any technical issue, you can search for some keyword in the documentation, and you will probably find some answer. And if you don't, you can always contact us via the support button that is on the top right, and that will send us an email, and we can help you. And finally, the main component, I would say, is Data Lab. This is kind of the technical entry point of EDITO. This is a place where you will be able to access computing resources, personal storage, and play around with the app, the processes. So I'm going to give you a little tour of the Data Lab, but first of all, little definitions about two main concepts that you will find in the Data Lab. The first one is what we call a service. So service is an application that is accessible through a URL. It can be launched for a limited period of time. For example, if you want to do some development in a fresh environment, you can launch a Jupyter Notebook or VS Code or RStudio and have a fresh workspace where you can develop everything you need. But you can also, service can also be something that is deployed permanently. So, for example, a what if scenario that you want to share among the community. So you can deploy it and under a permanent URL and yeah, share it, and everyone can access it, and it runs in on EDITO. And the second key concept of EDITO is what we call the process. That is temporary operation that takes input data and transform it into output data. So it's kind of a remote function, something that will be computed on the cloud, um, and that is finished in time. So it's something, it's a computation that you start, and it will finish once the computation is done. So it can be a model, it can be some data analysis. You can imagine all kind of computation that you will need to do um, onto data, or not even onto data, but yeah. So now we can go into the data lab, and I will give you a little tour of the data lab and its capabilities. Um, so here I'm already logged in. You can log in on the top right, and you are on the main page. So you will find on the left the different part of the data lab. So for example, the first one I can show you is the file explorer. This is your personal storage or your project storage if you are belonging to a project where you can store data, you can store anything that you want. It's just storage. You can do everything that you want with it. And it's accessible through the S3 technology. So yeah, to do anything with your storage, you have little command helper here in the yellow greenish bar here. And so you will find, for example, the ls command that will list the file. If you want to see yeah, to download the file, you can click on it. You can explore some subfolder, etc. And this storage is accessible so graphically via the UI, and also programmatically. You have My Secret. It's a secret manager. If you want to, yeah, store, you have some credentials that you want to store, or some things, some secrets that you want to store, and then can be then reused into services. You can do it there. Into the My Account, you will be able to configure some stuff that you might need to use services. One of these is Copernicus Marine credential. If you wish to use Copernicus Marine data, you can set your credential, your Copernicus Marine credential here, and they will be automatically ingested into services that rely on Copernicus, or that use Copernicus Marine tools, the toolbox, for example. And so you don't have to input them each time. It's stored securely in your account, and yeah. Public and private SSH key are also generated for your account. This is used for HPC integration. So if you want to launch things on HPC, you can use those keys that belongs to your account. You can configure some Git credential also to pull your Git repository, for example, automatically, for example. In the connect to storage, you will find your credential to access your personal storage. So you have all the tokens that are accessible here. Also, they are automatically ingested in services or processes that you launch, so you don't have to input them each time. Yeah, the Vault credential are for the secret manager, and some other stuff for interface preference. Then we can start to explore our service catalog. So we have two catalogs, or catalogs that are divided into two parts, the service one and the processes one. In the service one, you will find all the different services that the community have published. So they are sorted into different categories. And when you want to launch a service, for example, this Jupyter Python Ocean Science, that is a Jupyter notebook with some ocean science tools onboarded. When you want to launch it, you arrive on the configuration page. If you don't want to go into the details, you can launch it directly, and it will work. It will work. But you can also configure your services. So, for example, give it more resources. If you need more CPU or more memory, you can configure some sliders to define what resources your service will have access to. Here you can configure your Git repository if you want, for example, your repository to be cloned automatically when you launch the service. It can be convenient if you work on a project. The S3 configuration that we talked about earlier that allow you to connect with your storage. So all that is automatically ingested, the Copernicus Marine credential, your HPC key. So yeah, lots of configuration. You don't really need to worry about it if you don't need to. But yeah, you can configure your service with however you want. For example, have your project clone. You can save the configuration if you happy with it and simply launch it. And yeah, it will launch. It can take a few seconds or minutes. It's pretty quick generally. But yeah, once it's launched, you can yeah, open it, and you will have access to the Jupyter notebook. So here I see that it triggers a scale up. So it might take a bit more time than usual for that, but it's okay. We can come back to that later. Then the process catalog, where you can find a list of processes. So as we said, it's a remote function, a computation that is finished in time. Once again, it's divided into different categories, so you can see what people have contributed to, and you configure it like a services. So your process might need some resources. You have access to S3 if it produce data. It will end up in your file personal storage. And some process input. So, for example, for this marine plastic exposure, you can choose a year, a month, some a geographical extent, or yeah. And everyone that is a process that you want to make configurable for user, you can do whatever you want, choose whatever field you want to do that. So yeah, I think that's it for the tour of the data lab. This is an overview of what you can do to explore the data lab, and now we will go a bit deeper into how to use it with I think Loring.
Indeed, but I guess if there are questions first, we will discuss those.
Yes, absolutely.
Yeah, I think you can go ahead. I don't see any questions on Slido, so I think we're good to go with our presentation.
Okay. So I hope you can see my screen and
Yes.
can still hear me.
Yeah.
So I'm happy that Mattis clicked on what he clicked, because it's a nice transition towards the second presentation, which is about not only exploring the things as Mattis did, but also start to create something new. And I would like to explain that. I'm Lorenz Meisaros from Deltares, and I'm presenting this because I'm part of the EDITO Model Lab project, just like Camilo and Francisco, your hosts today. So before beginning with a bit of use case, I brought to you one use case that I've recently created, but I wanted to summarize what is the upgrade from Explore towards creation. And that is basically not only to to really get acquainted with all of the functionalities, but to really start to design, assemble, run applications with really a range of tools that you might prefer to use. And that already allows you to take advantage of this collocation of data and computing. You can already start to collaborate, but most importantly, you can build all kinds of applications that are reproducible. So you can also make use of the pre-existing things. Of course, that's the benefit of creation. And these can be predefined processes, as Matis just showed. Also predefined services, either things like IDEs, so things like Jupyter Notebook or VS Code, but it could be an entire other service or what if application that another institute has already developed. So you can also integrate that into your workflow. And you could do everything inside a launched environment, but I think it's also a good practice, or often it's easier if you work on external platforms, just like GitLab or GitHub. And there you can, as Matis said, you can just bring that to your new launched process or service. And as it was mentioned, in the creation, you can already use APIs like Copernicus Marine. So that is kind of the offer that we are going to investigate with one use case. And this use case is just for you to have a bit of background. The objective here is to launch a Jupyter Notebook-based application that represents a what-if scenario to test nature-based solutions to coastal flooding. I guess that's something that resonates with your group. And that this not only uses a Jupyter Notebook, but it also builds on or incorporates an existing process, which is a physical model, but it's a reduced physics model that makes it faster. And it's also GPU accelerated. So it's a perfect match for what-if scenarios because it calculates really fast. And ultimately, what you are going to see here is the animation on the bottom. This is a small coastal area with seagrass in the UK. And what you see is the flood depth with the flood wave coming and how the seagrass with certain sea levels rise scenarios would reduce this flood. And the steps that we have to take is, actually, I will show you what I have in an external GitHub repository, how to launch an existing EDITO service, the one that actually Matis just showed you how to launch. So you saw it interactively. And then I use my way of enriching this notebook. I will show you that. And I will bring you to two important elements on how to communicate with the EDITO cloud storage and also how to launch a process that's already on the platform. So that's the plan for this session. So step number one in my case was just to work on our company research GitHub repository, where I just created a kind of a sub-project for this nature-based solution. And here I put basically everything that I needed for this application. So what you hear is a small directory for some input files. In some other cases, we build everything from scratch, but since it's so local, we had to process a few inputs. So I'm going to grab that and put it in the Jupyter service before or later on. So that's in the input directory. I have a bunch of helper functions. That's because I want my main notebook to look quite neat. So everything else I wanted to move out. And as you see in the names, these will help me to move data back and forth, the EDITO storage. It will enable me to launch processes, but also I have different scripts to help plotting or making movies or all of these. Then I have this bash script highlighted in yellow. In the next slide, I will explain what I'm doing there. And then ultimately the notebook that actually I want to work in this Jupyter server. So let's see the initialization script. Here I really need specific packages, so more than what you will get in this standard Python Ocean Science Jupyter notebook. So here I install my own packages, and I also make it a default computational kernel in the notebook, and I get the input data files, the notebook itself, and all the scripts. So the first step is then just repeating what Maris did in the service catalog, looking for one of the suitable existing elements. In this case, I'm choosing the same that he did, that he chose. When I'm in the configuration, I can already feel like a god. I can rename it. I can choose a friendly name. So that's where creation starts, when you can name something. So I named it the Nature-Based Solution Sphinx. And then I didn't use the Git functionality. I'm always surprised there are always new ways to deal with things. I did the way we used to do at the beginning of EDITO, which was to initialize it. And here I use my init bash script, the link to it. So that will basically just tell the Jupyter server to execute that, and whatever that's inside is going to be executed, and then my environment will be prepared for me. What's also nice that you can save these changes, so they remain configured like that, and you can even have a link to auto launch this URL. So you can share that link, or you can save it for yourself. So even without going into contribution, that will be explained by Samuel later, you can already have a nice app that is only for you or your collaborators. So the next step, once you clicked on it, just like you saw, it starts the container, and ultimately it can take a few minutes. That new service appears, and then you can start to open it and interact. For this, I prepared a small video to see how it looks like, and then after that, I'm going to explain a bit the insider part, which is communication with the cloud storage, and also launching a process. But I will first walk you through this small application that I built with the creation functionality. So once I open, I will get a password that I copy, and I can launch my service. You see everything is already there. It's a nice, neat notebook that starts with some basic inputs for the user, such as grid resolution, what is the coefficient for seagrass, for example, and the sea level rise. Then I can start the whole workflow. Here I added also functionality for the EDITO username that I will need for the process API. So once I have that, my workflow will execute. I import the data files. I initialize my coastal model with grid and topography. It loads boundary conditions and different meteorological forcings. It adds the seagrass roughness to it. And it writes the whole model configuration, first locally in this Jupyter environment. You see there, the configuration is there, and then it is being uploaded later on to the EDITO storage. And that I will show you later, the insider knowledge. But if you check your file explorer, you will see in this case that I had it in the Sphinx inputs. Everything is already visible from the EDITO platform, not only in this Jupyter environment. And then I even launched the computation through the process API, and I can monitor there that it's still running. You can also check it on the platform with the user interface. Then you see what's happening, how new pods are being created, the container started. But if you don't want to, you don't have to lead this application, and then you will see that it's successful. And I can import back the simulation output from the platform back to this environment. So you will see that I have, for example, the no vegetation scenario. I have my netcdf files. And then I can repeat the same for another scenario. Again, prepare files, again, launch things, import back, and visualize them. So what I visualize here is just to see the tidal waves, the flood waves coming, but also the impact of vegetation, which reduces the water depth in the peak water depth. But I also created a few snapshots and created a video that I, in the end, upload fully to my storage. And there I can investigate the same things. Here I decided not to upload the data, only the final images, like the time series, like the difference time series, and a short movie that you have just seen. So this was a small application that could be created. But I also want to show you what's going on behind. If you launch another small service, you can get into this Kubernetes scripts where you see what was launched. You see there was some GPU process launched. And if you check the logs of it, you see that I've downloaded input files, and I made a simulation that actually lasted only 13 seconds. Then I closed off and sent the data back to the platform. So this is the application that was done in creation mode, so it's only for me. Ultimately, I also contributed, so I created the templates, but you will hear much more on that from Samuel. So the only thing I want to mention now is how we can interact with the cloud storage. So in my notebook, I had this one-liner where I said I want to upload whatever is in my notebook to my S3 bucket, which is the cloud bucket of the platform. And for that, I had a couple of lines. But what's nice is that already this service ingests a couple of environmental variables. So you don't have to hard code anything. You get those. And then it's up to you what you use. Here I used a package called S3FS that can upload data. It can remove data. So this could be much shorter or much longer. These are all choices that we make. But it's a small helper function that helps me to upload all the data, and then you can monitor this also through the interface. And the second one is to interact with the process API. It's super nice because if I contributed the Sphinx CPU and GPU version of the model to the EDITO platform, so that was contribution. But in the creation, I can now use it, and that is done with again with a few lines. Here I created an EDITO client which says I have this process on the playground called Sphinx run Docker GPU. I give some resources to it, and I can call it nicely, monitor it, whether it's running or successful, again through the API or through the interface. So with this, I can create a really nice small application that could be shared and contributed forward, or just kept for myself. So that's it from my side. And I hope Samuel's steps will bring this forward. And of course, if you have any questions, please put it in the chat, either right now, or if you have to give it some minutes, then please type it while Samuel is talking. So thank you very much.
Thanks a lot for the presentation. I think it was quite clear. I even learned things, so
Okay.
well done. So yeah, I don't see any question on the Slido for now. So yeah, I don't know if it's because people don't have the link to it or if it's just really, really clear and they understand everything. Okay, so yeah, I will just share the QR code if people want to have the Slido with the phone.
We can always discuss everything at the very end.
Yeah.
But it's good to check if it's not technical problems.
Yeah. So yeah, I'm currently showing the QR code to access the Slido where you can ask the question. So yeah, don't hesitate to scan it if you have questions for the speakers. Yeah, I will leave it a few seconds to give you time to take your phone and scan. So I'll just see if I see questions coming. Okay. Okay, yeah. So yeah, I will let Samuel start his presentation, but Camillo, don't hesitate to let us know if you need the QR code again or the link. Okay. Stop sharing. And yeah, Samuel, whenever you want, you can start your presentation, I guess.
Okay, yes. Sorry, I'm just trying to figure out. I'm using the browser version of Zoom, and I may not be able to share my screen. So maybe we'll have to do this via. Maybe Lorenk, were you on the, or was someone on the master file there? And we can just do it.
I can share it from my side.
I think that might have to be, because I'm not seeing anywhere to be able to share my screen on Zoom, which is really weird. I'm used to using Teams. Awful.
Yeah, I think people can see it.
Okay, great. So yes, I'll be talking today about contributing to the platform. So in my presentation, I'll go over about contributing processes, contributing your own services, and then also at a simpler level, tutorials, how to contribute those as well. So if Lorenk, you could go to the next slide. So yeah, just a little overview of what we'll be talking about. So service you can think of as like the interactive web applications. So what Matisse was showing, your VS Code instances, these kinds of things. And a process, what Lorenz was presenting there about more like a model or a calculation, something that's finite. It needs a certain amount of provision, but it will run and it will stop. And then tutorials is when, yeah, you want a lot more interaction, but the idea is that, yeah, it has more of an instructional level as opposed to a solid service. Yeah. So, of course, some things that you need, this has probably been gone over, of course. So sign up to be a beta tester. You will also need to be a contributor to the GitLab at this moment. There are some simplifications that are happening to contributing processes and servers that we'll get into later, but as of right now, you'll have to be a contributor. You will need Docker, and you'll need some sort of container registry or an account on Docker Hub. And then you need access to the playground repositories, which we will get into in just a bit. Yeah. So a process, like I was saying, and like Lorenz was saying, it's finite. Probably will take some input data or take some inputs. It will do some calculations, transformations, and will bring something out of it. It will run as a batch job. It runs as a job actually on the Kubernetes cluster when you look at the logs. And I just give an example of one that I've made as a demo for other tutorials. So you have a Docker file there. You have a couple scripts that will run. They do the data prep, do some analysis, and that's a good starting point, we could say. Next slide, please. So for those of you that haven't Dockerized anything, that's what this is in the past when I was giving this tutorials for people that weren't as familiar with it. So sort of a typical layout of a Docker file. This is building from Rocker, so an R-based image or whatever from start. You just add in some other necessary libraries. You copy the scripts into the Docker, but this is basically how we will build that containerized application that anyone, anywhere could use, inclusive of the EDITO infrastructure. Now, next slide, please. So you should set up a container repository. I recommend that one the most, but you can also have a Docker Hub, and your just accounts on Docker Hub as well, as long as your image is public. But if you set up a container repository, you have a token to get into it. So what you'll do is that application that you set up there with that Docker file, the scripts, you'll build it, test it locally, push it onto your container repository or into Docker Hub, and then get rid of it on your machine just to make sure that it's not rebuilding and using it there, and then test it from that container repository. Just make sure that your application, your process is doing what it should. Okay, next slide. So you'll go to this website for the process playgrounds. And then you have to clone it. You have to clone that process playground repository. That's where, and the steps after this, that's where it's important to be a contributor to these repositories. So after you've cloned it, you'll see examples of other processes that are there. You'll see templates basically on how you can set up your process. So you'll see there in the bottom right, we have, yeah, I've just called it my process workflow. So there's a chart that that's one aspect of the deployment. There's some other values in a JSON schema that you should fill in, but the key part is in the job. The job is where your container will be referenced. That's the process that you're running. So you have to configure that deployment. There are instructions for sure. Read the README, and then look for templates. Look for templates that are look for other processes that are similar to yours to use as a template. So something that runs in a similar way, takes data from somewhere, does some process with its Docker image, and then outputs it, what have you. Once you've made your own version of that deployment, you commit it to the process playground, you push it, and then you make a merge request. And once that merge request goes through, it comes up in the catalog. So these are some tips that I've put in there. A lot of words there. There's just some tips to help you debug through things. Make a modular execution. It's easier to diagnose. Don't do all of download your data, process the data, output the data all in one thing. Make it nice and modular so you can see what might go wrong where. Init containers are great. They will for sure make sure that things run in sequence. Have an upload container at the end. Make sure that your shared volume, make sure that the volume in the deployment is enough. Otherwise, you have things failing constantly. And of course, the resource management is an important aspect. Yeah. Next slide. So now we'll go into contributing a service. It's very similar to process. The only difference is what the underlying aspect is, right? These are interactive applications. They're not finite. So it's more or less a user choice, but we could say from our standpoint, as a contributor standpoint, it's a very similar flow. So you see there the service catalog and you see the general structure there for service. You also have a Docker file, you have some sort of application. In this example, I use an rshiny, the standard format for an rshiny application. And that can be a good example of a service. Next slide, please. So, like I said, very similar to process. You see how you would Dockerize that application right there on the right-hand side, following a very, very similar. The only difference being it exposes that port 3838 at the bottom, and it's going to start that rshiny server. You're going to do the same thing. You push that built image to a container registry or to your own Docker hub. Test it out and make sure that it works. And next slide, please. Then you will clone the service playground, not the process playground. So there in the service playground, you'll see other people's services that are there that they've deployed. And again, you can use those as a template. You can look up a service that's similar to your own, and you just tweak some things, and your service should deploy without errors or issues as well. So next slide, please. So again, read the README. It's going to go over some important things, but it's the same as with the process. So you alter some things with the deployments, mostly with the deployment YAML there. It's making sure that it's pulling your Docker image. You'll have to make sure that the amount of resources for your service is getting configured properly. But yeah, once you make those changes, you commit them, you push them, merge request, and your service will come up in the EDITO service catalog under the playgrounds. So you can see there, those are some examples of some applications that are in the playground that people have deployed. There's also one that's an auto deployment for a Shiny app, a nice new addition. But yes, can you go to the next slide? So now we'll go lastly into how to contribute a tutorial. So when you have something that you want to contribute, but it's just, you're like, I just want to show someone a notebook or an R Markdown or something. I don't need this whole interactive application or not a serious model, but I want to show some people some stuff that I learned and some stuff that I can run. So the general steps are, you have that notebook. You'll put it onto a public Git repository. You'll configure an auto launch or a deployment URL, which we'll go into a bit. You'll just change one part of the tutorial's content and then again, merge request. So next slide, please, Lori. So general formats of a tutorial there. You have the R Markdown, or you have the notebook that you'd be working with, some prerequisites, some simple data or config files, and a Docker Compose. I use that. I would put that in my Git repository. It's just going to ensure that anyone who wants to test and run it locally is going to have the right environment to do it. It's just kind of a, we should all use Docker. Everyone should use Docker all the time. Anyway. So commit that to a public GitHub, yes, and then you will have to go into the data lab. And what's Lorenz and I think Matisse showed in theirs as well in the explore parts. So when you're configuring a service, when you're setting up a service, you're able to add a Git repository in the configuration, which will automatically pull from that repository, or if there's a token needed to pull from it, you can include that as well. But the idea is when you're configuring that service that you'll choose the right base image. So is it an RStudio or whatever? You will put in the link to your Git repository. You'll choose an adequate amount of resources. And in the search bar in the top, there's a deployment URL. So that's the URL that will actually be sent to the EDITO infrastructure to tell it to launch that. So you will copy that, and you'll that's going to be necessary for the following steps. So next slide, please. So you clone, but this is not a playground. It's just the tutorials repository, and then you make a new branch on it. The difference is here, because there's no deployments that you're telling that you have to make to the cluster, not in the to the infrastructure, not in the same format as it was. There is a long JSON file. And basically what you can do is add your tutorial just as this descriptive metadata to that JSON file. And again, you can use existing examples that are in that long JSON. So you see in the bottom right there, an example. So the name, my new tutorial, a description, who you are, a little bit of the topics that it could go over, some keywords. And then you see there at the bottom, it says deployment URL. That's what you generated from the previous step when you were configuring that service. So that service that's what's important to pass on to everyone, is that they have a pre-configured service with the right amount of resources that pulls from your Git repository that has that notebook in it. And then people just click a button and they see what it is you want to share. So just a little quick chart overview it's not very clear for everyone, what is a tutorial, what is a service, what is a process, when to use them, how to contribute them. So there you go. Tutorial R Markdown, Jupyter Notebook, you commit it to the tutorial's content. A service would be an interactive application. You do need a container registry or a Docker Hub, and that's on the service playground. A process would be a batch job. Again, you need container registry or a Docker Hub, and you're pushing that to the process playground. All right. thanks a lot for your attention. There's some links to the documentation that you'll find on the EDITO platform, and there's some other resources. There's a GitHub that I've made with some workshops and presentations that you all can access with some extra info, maybe a little more details than what I could give now. All right, thanks a bunch.
Thanks a lot, Samuel, for the presentation. So yeah, the slides will be made available soon, so you will be able to access the extra links of Samuel. And yeah, thanks, Lorinx, for the for the help with the slides. So yeah, we don't have any questions now, so I don't know, Camillo, if you want to take the break now, and then if we have questions after the break, we can take them. And yeah, we can also test the audio on your side. So yeah, I don't see any questions coming, so I guess the coffee break is half an hour, if I'm not mistaken. So yeah, we can come back in half an hour, and yeah, we will finish with the Camillo's demonstration.
So see you in half an hour, right?
Yeah. I do the
I guess.
audio test with Camillo. You can take the break also.
Yeah. If you have to leave, Samuel, I think we can cover for you. But if you have time, it would be nice if you are back in half an hour.
Yeah, I will see. I will see if I can extend my stay, and at least I can at least try to watch the chat. I will do my best to at least try to watch the chat.
Okay.
All right.
Sorry, when do we get back?
In half an hour.
Okay, all right.
Yeah. See you.
See you.
See you.
Hello. Ellos te deben poder escuchar. A ver si te escuchan.
No, yeah,
Cambiado.
I guess you are using this now.
Now I'm using that one, but lo oye y ya está.
Yeah.
¿Ya está? Ahora tú puedes hablar, ellos te van a escuchar y cuando ellos hablen va a salir a través de aquí. Y porque normalmente cuando hablas aquí no te escuchas a ti. Y tú te estás conectado, me podrías escuchar ahora. Sí. Ya.
But if you want to can connect to the television, or you will share your screen to the other people see in the television.
Francisco, can you hear me? From there? Okay, cool.
Funciona, ¿no?
Parece que sí.
It's okay.
Gael vuelve en 3 minutos, patrón. Vale. Cerrar el micro, si no. Gael, can you hear me?
Yes, I can hear you.
Okay, now it's good. We can hear you. And I don't
Yeah.
think there
Yeah,
is no.
I don't have.
So it's good on your side?
Yeah, no echo.
Okay, so we can. I'm using my computer, so we will use this one for the next
Okay.
part of the session, okay?
Okay, perfect.
A bit. Bye.
Bye.
Hi, Camilo. Can you hear us?
Yeah. What about, can you hear me now?
Yes.
Okay.
Perfect.
Cool. So,
Yep.
right, everybody, we are going to start with the second part of this training session. So, I don't know if you had the opportunity to register to the EDITO platform last week. We shared information. So I'm not sure whether you have the resources, if you requested computational resources. And so what I'm going to do now is I'm going to share my screen and present a few slides and guide you through how to run a simple application and how to interact with the platform. So
Just before you start, Camillo,
yeah,
for the participants that are on Zoom, if you want to communicate with Samuel, Lorinx, or Mathis during Camillo's presentation, you can use the Q&A option on the Zoom window. It will allow you to chat directly with the online support if you need to. And yeah, that's it.
okay. So now this is the hands-on session. So for this part of the session, we would like to show you how to become familiar with the platform. This part is not that technical as the previous one, although they presented really nice things you can do with the platform. I think it is still too technical for like newcomers to the platform. So now I want to show you how to basic interactions with the platform, transfer data from the personal storage to a working workspace. And also we are going to run an application we developed in the EDITO Model Lab project. It's called the Validation Toolbox. It's for validating ocean model output. So it's integrated into EDITO platform, and you can use it if you have a model simulation. You can use it to validate your output. So let's start this part. So before we start, Mathis already mentioned this, that it is important for this and other applications to provide like the credentials to the Copernicus Marine Toolbox, so you can access data from the Copernicus data store directly without providing the credentials anytime you want to access to this data. So for doing that, you can go to my account, and in the profile tab, there is, as Mathis showed before, you provide your credentials. That you can also configure like other secrets, but that's kind of more advanced features that is all well documented. But this part is important for many services and processes load data directly from there. So this is a useful feature. Also, in this My Account, there is another tab that is called Connect to Storage. So there you will find how to the init script, as similar to what Lorin showed, how to configure the applications in Python or in R, or also in the command line from Jupyter Ocean service. And you can save data directly to your personal storage, or you can also provide like public access to the data you have stored there, so you can access the data outside the data lab. So that is also a very useful feature that is interesting to know. Also, this part is how to interact with the personal storage with my files section of the platform. I'm going to show an example later on. So with using, this is MinIO command line tools, you can copy files, copy directories, or do whatever you do normally with your own laptop. You can do the same there in the EDITO platform. So right now we are going to deep dive into this EDITO validation toolbox. And basically this is a Python package that provides like different tools for validating ocean model output. It is useful for data preprocessing, metrics calculation, and it creates like a validation report after the workflow is completed. And I'm going to show a short demonstration, but you can run this application as well if you have the resources. So you will find that it's useful not only to use the validation toolbox and validate model output, but also to become familiar with the platform. And the validation toolbox, I mean, we integrated this into EDITO, and you can launch the service. I'm going to show that in a minute. And you can use this via Jupyter Notebook, and it will open a couple of tutorials where you can validate grid day data or your model output against in situ observations. So there are a few tutorials where you can follow and get familiar with how this toolbox works and how to validate model output using this one. It is, let's say, efficient because it's a caching mechanism is implemented, so it's memory efficient. So we will see that in more detail. Also, we provide like a basic functions to validate models, but it is designed to be extensible so more expert users can implement new functionalities to the toolbox and perform additional validations than the basic core functionalities. So this is the workflow, the workflow. So there is like a configuration file that is in YAML or JSON format, and this provides like the basic configuration you need. Where is your model data stored? What type of Copernicus product you want to use for validate your model? Then this tool will automatically run, and it follows this series of steps until the final part that it creates a validation report. So this is like the tutorial on how to use it. We go to the My Services service catalog, and then there we will find validation toolbox. And once the Learn More button directs you to the source code, so you can also download your code to your laptop, to your personal computer, and use the toolbox directly there, or you can launch the service and use it in EDITO. Once this service is deployed into the platform, it will open a Jupyter Lab workspace with these folders. One is the configuration files. There are a few examples. Also, there are some scripts that are used to run the validation, and a notebooks tutorials that guides the users on how to do it. This is the configuration file. You will only need to provide like where's your data, as I said, which variable you want to validate, but I will show you an example in a minute. And also there are 3 tutorials that you can follow and validate grid data or in situ observations against moorings data or against Argo float, and we are also implementing the validation against tide gauge in situ data. But this part of in situ data is a bit more complicated than the grid data set, so we are still improving this toolbox. Okay, this is like the workflow again. You will have access to this presentation, so there's no need to explain everything now. And this is the final validation report that is in an HTML format, so you can share. This is like the basic validation. This is for SST. This is an example of model output from sorry, I forgot to mention, I'm Camilo. I work in SOSIP. So this is the Balearic Island Observing Forecasting System. So we run operationally a forecasting system for the Western Mediterranean. So in this example, I'm going to show, I'm going to validate our data, our output for some period, just for for testing purposes. But this is the type of report that produces. You can share the report in HTML format. So finally, before I jump into the into the demonstration. I would like also to share that we run a hackathon, a long hackathon where we have like a period of training, because getting familiar with all the functionalities of the platform is not that easy. So we came up with the idea of having a 3-month training where we train participants on how to, from the very basic things up to the more advanced features, as the one that Lorenz and Samuel just showed, how to integrate your applications. And all the material that we use for this training is now publicly available, and you will have access to that. So if you are interested in knowing more about this, we will share there is a website with all the material, recordings, and presentation that is very useful material for you to start to work in more detail with the application, with the platform. Okay, this is not on par. I'm going to share now my screen. Okay. So this is like the EDITO platform. I'm right now on my account. So if I go to the service catalog, this is how we run services or processes. You go to the, I don't know how familiar are you with the EDITO platform. I'm trying to say some very basic things so you can more or less follow what I'm trying to say. So there is a service catalog and there is the process catalog, as Mattis presented before. Services are like interfaces where the user can interact with the application, while the processes are like computations that you run and it outputs some files to your personal storage. But in this case, we are going to the service catalog. They don't. Okay, now. So this is my services. I can go to the service catalog, and there are many applications that have been integrated by different institutions. In the EDITO Model Lab project, we integrated many applications, but also some other projects have integrated their own applications or services or digital twins, whatever you want to call it. So in this case, I'm going to look for the validation toolbox. So if I click on this Learn More button, it directs me to the source code that is stored in a GitLab repository, and it's all documented. So if anybody's interested, you can go and take a look at that. So now this is how we run the services. We simply click on the launch button, and here you can configure all the resources, computational resources you want to use. In this case, we are not running something complicated, so the default resources are fine. And now I launch the service. It will take 1 minute or two. Right now, it is like pulling the Docker image, as Samuel showed. It's pulling the Docker image and it's deploying all the configuration and all the applications into the virtual machine. So right now it's doing that. It will take no more than 1 or 2 minutes. Okay, I have opened a service before in case this is not working, so I can show you the result. So if you have registered to the platform, you can also run this demonstration I'm running, or you can open a JupyterOcean service, and I will show you also how to start basic interactions with the platform. So okay, now the application is deployed into the platform. So we copy this password. We will open. Okay, I'm assuming that most of you are familiar with using Jupyter notebooks or Python code, so that's why we are using this, that we believe like is very user-friendly. So okay, now we have this application running. So as I said, there's three folders. This is the configurations. So I'm going to present an example for SST validation for this Western Mediterranean region. So in this configuration file, you say, where is your model data stored? And in this case, there are a few examples. These data sets are stored in my personal S3 bucket in EDITO, and I gave like a public access so everybody can access these data sets. So. So there are some basic options, but you can configure it as you want. Just I need to tell the system which variable I want to validate. The variable names change from dataset to dataset, so it's important to, you have to know something about your data before you run the validation. Okay, this is done. So now I go to tutorials, and there are two tutorials there. This one is for the gridded validation. I open this is a Jupyter notebook, and it will guide me through run the entire validation. So first I have to import the toolbox. It will run it. It will import the different functions to fetch the model data and the observational data set. So now it's complete. Then the configuration. Here I'm basically loading the file I just edited, the YAML file. It's run pretty fast. Just I want to check the configuration, and this is fine. And now this is the part where I run the validation. It's a step-by-step guide. So first I read the data sets. It will take no long time because this is very efficient, I would say. So now it's showing like messages, and it provides like a summary report when this is done with the mean metrics and statistics. And now that everything runs fine, I think I use a very short time period just to do it fast. And now I can generate the plots because everything has been imported into this Jupyter workspace. And now it's creating the plots. So this aims at providing like a general basic validation of models so everybody can use it. But if you want more in-depth validation, the toolbox will save like the files in its netcdf format to this output folder. So you can also take a look at the results using the output from this, in this case, for SST. And it provides the metrics in netcdf format so the users can also interact with that. Okay, now I think it's complete. And now it's saved, as I said, these netcdf files. I just want to have a look at those files. Okay, it's a simple plot. This is the root mean square error for this validation. And also I want to take a look at the validation report. So it's stored here. Very similar than the one I showed before. So it provides like basic metrics, information about the data you validated. I run it everything right now. This was not like pre-computed or something or anything. I did it in 5 minutes. So this is the type of report that it provides. And also this works the same for in situ data. This is the gridded part for SST, but other variables can be also validated against gridded products or in situ data. So this is it, basically. But there is one last part I would like to show. So everything that is created now is stored in the current workspace. So if I exit the service and delete it, everything will be removed from there. So I don't want that to happen. So I can copy those files to my personal storage. So this is very easy. And this is the part I showed at the beginning, how to interact with the personal storage. So in my account tab and interact with your personal storage, you can get the credentials and just put the credentials in this part. Then you have to provide your user ID. In my case is Melon. And now with this code, I will move this data to my personal storage. So it is there now, and I can open this report in HTML format and share it with other colleagues or whatever. So yeah, basically this is what I wanted to show. And also, this is similar to the Jupyter Ocean science service that Lorin showed before. But if I want to take a look at the things that I created, I can open a terminal and I can start like normally when you work on your laptops, you can just take a look at the files you have there. Sorry, I just want to show this part because this is other way to interact with your personal storage. There are these command line tools called MinIO that allows us to save data to this S3 bucket that is the personal storage. So if I want to, for instance, list all the files I have there on my personal storage, just go to File Explorer. So there is my data, and also if I'm part of a project, there is also another part for that project. So this is all the things I have here. So I can move like files, copy everything from the workspace to the personal storage, so I can access the data outside of the service I just run. So these comments I can. Okay, this is fine. It says I don't have the credentials, but this is what I wanted really to show. You go to this part, my account.
Camilo, you just forget to put S3/ before, but
okay.
You can copy paste the command from the file the file explorer directly. It's shown on the top right. It's a good tip to show.
Yeah, thank you very much, Matis. So you go here, and we have this command. So I can copy and put it here. So, okay, I just wanted to show that you can interact with your personal storage from here. You can also give public access to the data you have stored there, so you can load the data or use that data outside the data lab. That is very useful feature. So yeah, basically, I think I will finish my presentation now. And if you feel like doing something on the platform, you can start Jupyter Notebook service, the validation toolbox, and I'm here in case you have any doubts, I can help you to run things. Also, we have our colleagues online that they are providing support for this session. So in case you want to run anything and ask them whatever, it's a good opportunity because they are real experts on this matter. So it's good to have them online providing this support in case you want to run a service or anything, or this validation toolbox or whatever. So Gael, and I think that's it from my side.